Okay, so welcome to week 3 of the course. We'll talk about cable types, service conductors, and portable cords. Cable types and service conductors we will cover today online, and the portable cords we will talk about tomorrow when we have the class in person. All right. So we just have finished multimeters. Please do not forget to watch that video, the YouTube I think it's 16-minute YouTube video on how to read analog meters. Maybe we're going to have time tomorrow to do a little practicing, do a couple of exercises on how to read the analog scale on the analog multimeter. I need you to know how to do this. Right? There's no way you're going to leave our school without knowing how to do this. Right? All right, so let's jump into our cables and service conductors. We're going to start with this here. No, this. There you go. First of all, we're going to distinguish between the solid core wire and the stranded wire. I would jump right into the description. What is a solid core wire? Well, it looks like this as opposed to something like that. Single strand or core wire, insulated with non-conductive materials. It's a single strand, one big chunk. Now, what's a stranded wire? It's a bundle of small gauge wires, and gauge talks about how thick or how thin, or it describes the thickness of the wire, of the conductor. So it's a bunch of, or a bundle of, smaller gauge wires bundled up and grouped together, insulated with non-conductive material, which will be the jacketing. Why do we need the jacketing, and why does it have to be non-conductive? Well, so the conductivity of the material can be separated from the conductivity of other materials. If we just had a bunch of bare copper wires, it just would not make sense, because we would create a bunch of circuit or short circuits. Now, when do we use, or where do we use one or the other? For the most part, the solid core wire is used in the household or commercial wiring. Your household wires, the wire that connects the electrical panel to your duplex receptacle in your kitchen or living room, is 99.9%, I can be sure that it's a solid core wire. Now, can you use a stranded wire to connect? Yes, you can. However, the preference stays with the solid core wire for a couple of reasons. One is that this here is more expensive, and there's no need for using that while there is a permanent non-vibrating environment. So you could have that in a household or commercial installations, but this is being used. The other reason is that, permanent installations, what was disadvantages here? We'll talk about that. This one will tend to corrode quicker than that, and we'll talk about that. You can have the insperma. Now, see, here's where the difference is. The solid core wire is typically in-wall power cabling. So in walls, you're going to have those solid core wires installed. This stranded, you're going to find in moving or vibrating parts, typically in industrial environment. The reason for that is that the solid core conductor will carry the vibrations more efficiently, which we don't want, throughout the conductor. This one here, the vibrations are not carried through as much, if any, are being carried, because they just die out because of the flexibility of the conductor. Right? So when you see industrial installations like machinery that have a lot of vibration and whatnot, there's some movement going on, you're going to see a stranded core, stranded cables, stranded wires. If you pop the hood of a car, you're not going to see any solid core wires there, because car engine is always vibrating. Yeah? All right, advantages, one or the other. Well, the solid core wire is less expensive to produce. And it has more compact diameter. It's physically not as bulky as the stranded wire. Why is that? Well, excuse me. Excuse me. So, in order to accomplish the same so-called ampacity, and what is ampacity? Ampacity is the ability to conduct a certain amount of current. So, certain amount of ampacity demands a certain amount of copper to be able to carry it. So you have to have the same volume of copper to accomplish the same ampacity. However, in this here, you can just compact this thing in one single core. And over here, you have a bunch of smaller ones kind of bunched up together. So of course, they're going to take more space. So that's why when you see wire strippers, you're going to see two grooves for stripping solid core or stranded. You're going to see a groove that is labeled 14, for example, gauge 14. You're going to see, for example, 14 solid and 14 stranded, and the 14 stranded is going to be slightly bigger groove to accommodate the, well, the size, bigger size, physically size. Now, they have to be able to carry the same amount of current, and they have the same amount of copper. This is more compact. This is, well, bunched up together, so it's going to take more space. Okay, I said it twice. So it takes less space. Oh, when I say, okay, it's just a minimal. Well, yeah, but if you have 200 conductors going there, it's going to make a difference. And here's another advantage of this here. Solid core is less likely to fail due to corrosion, because most of the copper is contained within, and there's just a certain amount of copper that is exposed to the elements. Over here, you have exposure here, you have exposure here, you have everything is exposed, it's like chopped up, and there's more area exposed to the elements, so it can react with moisture and whatnot. So of course, this would be more likely to corrode quicker than that. Now let's take advantages of the stranded wire. Very flexible and withstands a greater amount of flexing and vibration. We just talked about that. And it's easier to route, well, because it's more flexible, easier to install. Disadvantages of both of them. Solid core. Well, typically only available in smaller gauges. What's a smaller gauge? We'll talk about gauges. A gauge is describing how thick the wire is, or how thin. It was describing the thickness of the wire. So the solid core wires are mostly available in not as thick versions. Just think about it. If you make it thicker and thicker and thicker, and if you have a solid core wire, all of a sudden you're going to find out that, well, you're not holding a conductor, you're holding a metal bar, and there's not much you can do with it, right? Because it doesn't flex as much. So to accomplish the little bit, better flexibility of the wire and possibility of installations, some of the thicker wires only are available in stranded versions. And of course, there are exceptions everywhere, but this is the general statement that I'm making here. Yes, in maybe some special cases, you would have very thick wire made out of solid core, but there will be, as I said, exceptions. Now, continuous flexing or vibration will cause the wire to fatigue or break. Because it's a solid core, it's more susceptible to carrying vibrations. And if you bend it and straighten out, bend it, at some point this thing is going to break. This is more flexible, this stranded wire. Now, disadvantages of the stranded wire. Diameter is larger. We talked about that. So it's physically going to take more space to accomplish the same ampacity. More costly to produce, of course, because the procedure will be more complex. And it's more likely to fail due to corrosion from capillary action of a high surface area, which means there's more area per copper volume, more area is exposed to the elements. So of course, if more area is exposed to elements, then this thing here is going to be more likely to corrode. Now, I'm going to stop this slide here. I'm going to let you read that. This slide, this presentation is going to be available for you to download right after this class. Read through that, and we're going to have a little discussion when we see each other tomorrow in person. Okay, now, second part of this thing here is right here. Household wiring and cables. Now, for some of us, it's going to be a repetition because we already had we touched on that subject a little bit during the first lab, and some of us haven't done the first lab yet. So this is going to be a little bit of a reinforcement of the knowledge of the information. And for the other guys or and girls, this when we see each other during the lab, that's going to be a bit of a reinforcement and repetition. So you at least are going to hear the same thing twice, and there is a reason for that. We need to make sure that you are comfortable with this type of information, with this type of knowledge. All right. First thing, what do we have? Here's a cable. A cable is, well, enclosed entity that encloses individual wires or conductors. What do we see here? This one says 14.2, this one says 14.3. What do we see here? Let's count the wires. 1, 2, 3. Where does it say 2? Because the second number tells us the number of conductors. And we have 3 conductors here. Is that a mistake? No, it's not a mistake. 14 tells us the gauge of the wiring. And remember, gauge describes the thickness of the wire. So this one here says 14.2, and we have 3 physical conductors. What's up with that? All right. Let me call up my Photoshop thing here. Whoa. Clear the board. Let's say we have a power supply that consists of a hot terminal. It consists of a neutral terminal. And it consists of a ground or bond terminal. And I'm going to stop here for a second and concentrate on this ground or bond. What's up with that again? Because sometimes you're going to hear bonding terminal or grounding terminal, bonding wire, grounding wire. And you could hear two different people calling the same thing two different ways. Well, here's the story. Here's the thing. If this terminal, let's say this terminal here, is connected with a single uninterrupted wire, and it's going somewhere outside the building or wherever, or maybe inside the building, connected to a true ground with either a spike or a plate buried or directly connected to something that's labeled as a true ground. Then we call that thing grounded, this terminal. Now we might have a second terminal here that has a wire connected to, let's say it's a grounding strip, all copper, for example, and there's another screw terminal, and this thing is connected to here. Technically, yes, because this is all connected. This is a copper bar, and these are just different screw terminals, so you can add on to this. So it's all connected. Yes, this terminal is also technically grounded because it's sitting at the same potential as ground because it's connected to ground, but it's not connected to ground with one uninterrupted wire. It is going to some connector first, and from there it goes to ground. So we call this thing bonded, and we call this thing grounded. Yeah. So you're going to hear me saying grounded or bonded interchangeably. All right. So we have the power supplied to us by some sort of receptacle or an outlet. Here's the hot terminal, here's the neutral terminal, and here is the bonding terminal, bonded terminal. And on the other side, we have something that is like a light bulb, for example. Here is the symbol for a light bulb. How do we complete the circuit? Well, we need to complete the loop. We need to complete the circuit. So the current will flow from the hot terminal. It is going to supply some energy to the whatever load we have. In this case, it's a light bulb, and it has to find its way back to the neutral. This way, there is a continuous flow of current. Now, of course, when it comes to AC, the current is not flowing one way. It just kind of goes back and forth, right? It's just like this. But we're not going to, just for the part of for the purpose of simplicity, we're just going to say that the current flows from hot to neutral. So under normal circumstances, under normal conditions, this hot wire and this neutral wire are considered a current carrying conductors. This one here it is supposed to be able to conduct current, but it is not employed to carry current under normal conditions. So let's say here is a device box, and it's a metal device box in which the light bulb is seated. Let's say the hot wire becomes detached from the terminal and by accident it touches the chassis, the metal chassis. If this were floating in the air, not connected to anything, then this chassis, this metal box, will become the same potential as hot, which means it will be, well, powered. If you touch that and if you complete the circuit to ground with your body, the electricity is going to flow through your body into the ground. So that's why we have a connection here. We bond the device box to the ground. So if the hot touches the box, the electricity is going to flow through the ground to the ground through this bonding wire. It's a safety wire. And what's going to happen? Of course, if it's connected to a circuit breaker, the circuit breaker is going to sense that there's too much current going on and is going to flip open, which means it's going to disconnect the whole circuit. So that's why, and let's say those wires are the gauge 14 gauge. AWG, American Wiring Gauge. If you see this, you can just read that as 14 gauge. We don't read the 14 AWG. All right. So how many current carrying conductors we have? Two. White is always neutral. And there's the other color. In this case, is black, and it's hot. Just remember, white is always neutral. And then there's that safety conductor. So we call this thing 14 too, because those wires are gauge 14, which is thick as gauge 14. The thickness of it is gauge 14. And there are two current carrying conductors. We don't count the bare copper wire. We don't count the safety wire. Over here, what do we have? We have 14.3. That means what we have here is three current carrying conductors, and those are gauge 14. So we're going to have, for sure, we're going to have white because that's the neutral. We're going to have black because that's the other one. And the next one will be colored red. So you could have two different circuits here. You could have a separate receptacle connected to the black wire, powered by the black wire, and you can have a separate circuit powered by the red wire and the black wire, and the red wire can be connected to two different separate circuit breakers. So you can have two circuits here. And of course, everything comes back on the white. There are different types of cables we're going to tackle as we go along. Here is the BX armored cable. This one is 2-wire cable, 3-wire cable. Some of them will have bonding wire and some of them won't. Here's an example of UF cable, under feeder cable, underground feeder, which means it can be directly buried in ground. And of course, we're going to be talking about gauges, 10 gauge, 12 gauge. In this case, what's presented here, excuse me, is that the wires could have different gauges. So 12 gauge and 10 gauge. The 10 gauge is thicker wire than the 12 because they're inversely proportional, the numbers. The number goes up, the gauge, the wire is thinner. The number goes down, the wire is thicker. All right. Now, we already talked about the differences between the solid core wire and the stranded wire. So that was the supplement material. And we have some multi-conductor wires. For example, what's this one here? 12-2. What does that tell us? That the gauge or the thickness of the wire is gauge 12, which is thicker than gauge 14. And there are two current carrying conductors. Okay, we got white, we got black, and we have the ground wire here. This one here will be 14-3. What does that tell us? It tells us that the thickness of the wire is of gauge 14, and there are three current carrying conductors. What's a current carrying conductor again? It's a conductor that is expected to carry the current under normal operations. The grounding wire or bonding wire is supposed to be able to carry the current as a safety measure if something goes wrong. And if you notice here, there are larger appliance cables, which means they require a thicker gauge. Notice that some of the thicker gauges are already supplied with stranded wiring just to kind of maintain the flexibility of the wire. Excuse me. When it comes to MC, which stands for metal clad, cladding is surrounding or embedding, sort of, so to speak. Sometimes it's called BX cable, and the BX stands for. Let's take a look at the X first. When the cable was developed, it was an experimental type of undertaking that I forgot what the company was that developed that cable for whatever purpose it was, and they were trying to develop some sort of a cable, and they called it an experimental cable. So that's why the X comes from, because it's experimental, and the B comes from because it's their second attempt. And that's how it stayed. Maybe the first attempt was called A, and then it's one called B, so BX. So that's the mystery solved between the mystery solved of why some of the cable is called BX. Okay. MC metal clad, or sometimes it's just called armored cable. And this one here, what does it have? It has, white, always neutral, white. Then there's a hot, which is black. And it also has a green jacketed cable right here. See that? Now, the grounding or bonding cable conductors, the colors for them are reserved as such, either bare copper wire or green jacket. That's in North America. Okay. Gauges and sizes. Oh, I think we have a rain outside. I wonder if you hear it. Now, you could see the comparison of the gauges. Gauge 14, gauge 12, gauge 10. See, the gauge number goes down, the wire becomes thicker. And notice that somewhere, starting with gauge number 8, the wire becomes only stranded. It's just to accommodate the possibility of the flexibility. Okay. Now, let's get to this thing here. Typical household wiring. What does it say here? The most common type of cable used in houses is technically known as NMD90. NMD stands for non-metallic dry service cable, rated at maximum 90 degrees Celsius. Right. What does the non-metallic mean? The non-metallic means that, it doesn't have metallic jacketing, so it's not MC, not metal clad, and it's not supposed to be installed onto a steel framing. You can only mount that cable on non-steel framing, which would be usually timber, wood framing. You can staple that cable with special staples, which we're going to use in the labs. You can mount that to the wooden structure. If you have steel structure, and if you want to install one of those, then you can, I've seen that done, you can fasten a, well, timber 2x4 to the steel structure, and then you can fasten the cable to the 2x4. So it's going to be mounted on wood, or you can run it inside a conduit. Right? So that's why it's non-metallic, dry. Well, you can't have that outside exposed to elements. It's supposed to be in a dry environment conditions. Right? And service cable. What does it say? That's, if you just, if you read it quickly, this might skip your attention. Service. What does it mean? Service. Service means it's a conductor or a cable that is providing power. What could be other type of cables? Well, microphones, there'll be signal cable, data cables, that will be also a signal cable, some control cables. This one is meant to provide power. Okay, so NMD90 stands for non-metallic dry service cable, rated at max. So it's rated to withstand up to 90 degrees Celsius. Of course, the boiling temperature of water is 100 degrees Celsius, so it's pretty hot. Right? Now, the brand name that is commonly called is Romex. So you might hear some of the older electricians call the cable Romex. Give me a box of Romex 14 gauge or something like that, right? It's because Romex was a company that was the only company that produced this type of cable some time ago. Now everybody and their brother produces that. So, but the name kind of, the jargon kind of stayed. Right? All right. The cable is usually configured in a 2 or 3 conductor combination. So it's like if it's gauge 14, it'll be 14.2 or 14.3, right? Or maybe 12.3. Two conductor having a black and white. So white is neutral and black is hot. And of course, bare copper wire. The bare copper wire is never counted. We just went over that when we are naming the cable. So 14.2 will have physically 3 wires in it. One of them is not counted. Which one is not counted is the bare copper wire, the safety wire, because it's not considered as current carrying conductor under normal conditions. The conductors are most commonly gauge 14. You see here, notice how I read this sentence. The conduct is, if you want to read it, just if I were like a artificial intelligence kind of a reader, I would say the conductors are most commonly hashtag 14AWG, right? Now you see that 14 gauge, American wiring gauge. You see that, you just read it as gauge. The cable is also comes in 2 or 3 wire 12 gauge, which is thicker. Remember we were talking about gauges. The number goes down, the conductor becomes thicker. Okay, so this is thinner, this is thicker. Household wiring. What can you see in the common household wiring? For the most part, you're going to see 14.2. See, I just like 14.2. Two conductor, 14 gauge. And it is commonly used for plugs, switches, lights. It is pretty much 70% of the household wiring. Most of it is going to be 14.2. 14.3. It's employed in 3-way switches, and we are going to analyze as we go along. We're going to analyze and we're going to connect a 3-way switch, and we're going to make it work. And in split receptacles, when you get some of us already completed the lab, I pointed out that there's a tab connecting 2 screws on each end. So we can connect it to one side, only one screw, and it means the other one is connected to it with a like copper or brass tab. You can break that, and if you break that, those 2 receptacles are becoming independent of each other, which means you have a split receptacle. And to one of them, you can apply, if you have a 14.3 gauge cable, neutral is going to be going to one of the sides where the neutral prong is, and then to, let's say, to the top, for example, receptacle, you can apply the black hot, and to the bottom one, you can apply the red hot. And the black and the red will be connected to separate circuit breakers in the electrical panel. So they'll be providing a separate circuits. Sometimes you want that. And when it comes to gauge 14, the ampacity, the rated ampacity is 15 amps, 1.5. Now, continuing, 12.2. So we're getting a thicker cable now. Instead of 14, we're getting 12, which is thicker cable. And look, instead of 15 amps, we are able to use that for appliances or loads that use maximum of 20 amps. So selected heaters, they take a little bit more juice than just a regular TV. Air compressors, air conditioning units, etc. Anything that uses maximum of 20 amps. Here is the gauge 12, which is thicker wire. Kitchen receptacle circuits. Here's a bit of a interesting thing about this. The difference in use between the regular living room or a bedroom receptacle is that in bedroom, you might plug in a clock radio or a lamp or something like that, or something that doesn't take much power. Now, when it comes to kitchen, let's imagine the situation. There's morning. In the morning, everybody gets up. Kids go to school, parents go to work. There's a toaster going, there's another toaster going, there's a coffee maker going, there's all kinds of the tea kettle and stuff that can overload the circuit. So in that case, we are going to install split circuits. So the receptacle is not a duplex receptacle, it's on two different circuits, and each is capable of providing 20 amps. This way, we don't overload the circuit. Now, mind you, it's not just enough to replace a circuit breaker for a bigger ampacity one at the electrical panel. We also need to make sure that the wire that's providing the service to that receptacle is a proper gauge, which means it's thick enough. Right? So we get 20, 12 gauge, 20. Remember, 14 gauge, 15. 12 gauge, 20 amps. 3 conductors, 10. So here is gauge number 10. What do we have? Any device that requires maximum of 30 amps. The most common application would be your electric dryer. Not a big philosophy there. So now you know. 3 conductors, 8. Well, gauge number 8, 40 amps. And the most common application would be your electric range, which is like electric stove. Okay. Now, a bit of a question. Household wiring is done. And I'm going to ask you to participate here. Where's my chat line? You can pipe in with voice as well if you want. Household wiring is done. What do you think? In series or in parallel, or depends upon whatever code in your area, or using wires dummy, whichever way is easy. So what do you think? What do you think the answer is? I was looking at the... No, I'm looking at the right window.
Would it be C because each area is different according to the code?
Thank you for piping in on the voice, and I appreciate that, but you don't get a candy.
Oh man.
I got parallel, I got some series. Okay.
I
Okay.
think it's parallel, but there almost certainly is exceptions where series is used. I just can't think of any myself.
Okay. All right. So thank you for thinking. Okay. Now let me explain something here. And now that I got your attention, where's my? Here's my board. Okay. Let's just erase this thing here. Now we have a hot terminal, we have a neutral terminal, we have a bonding terminal. Cool. And let's say we have appliances. For example, we have a receptacle into which we just plugged in a vacuum cleaner, right? And here's another receptacle to which we plug in a, let's say, electric drill. All right. And then we have another one that we have a refrigerator plugged in. Yeah, there we go. Now let's connect it in series. We're connecting it to here, just like the Christmas lights type of a series circuit. Then we connect to here, then we connect to here, and then we come back to neutral. What do we have here? Well, the circuit has to be complete. So in order for the fridge to work, then we have to turn on the vacuum cleaner and we have to turn on the drill. And then the fridge works because then the circuit is complete. So we couldn't find that. We couldn't have that. What we need to do is we need to connect this thing in parallel. So here's the second scenario. Here's hot, here's neutral, and here's ground, right? So now here is a receptacle, here's a receptacle, here's a receptacle. If we connect it in parallel, then each individual load can take can take the current from the main line independently. We use this receptacle, yeah, okay, we don't have to. We can use that one, or we can use that one. So the answer is that the household wiring is done in parallel. That's the answer is B. And for those who answered and were willing to participate, I thank you. My heart goes off to you guys because the world belongs to the brave. I keep saying that to myself as I run away. All right, before we go, a couple things. I'm going to leave you with this thing here, this picture. It's going to be available for download very soon. Read that and just we're going to have a little discussion on what possibly could be missing here that that this little line talks about. And one last slide here. Service conductors. Remember when we talk about service, we talk about conductors or cables that provide power for us, as opposed to a microphone cable that provides a signal. So here we have a scenario that the cables are connected in the overhead way. Okay. Sorry, I need to. Okay. So some of them are buried underground and some of them are provided overhead, just hanging. Those conductors, let me read this thing. There are specific cables used to carry power into the house to service panel. Here, these are the ones that go from here to the utility pole. These are referred as service conductors because they provide power. Service conductors that are run overhead are generally made out of aluminum because aluminum is lighter. A copper is a better material, technically, but when we are running the cables overhead, we hang them, then we use aluminum because it is lighter weight. That's the only reason why this thing is, why those conductors are aluminum. All right, so that's it for today's class, and I will see you tomorrow in person. Can't wait. Enjoy the rest of the Monday, guys. Thank you, and girls.
Thank you. Have a great rest of your day.
You as well. Where's my end button? There it is.